Right, paper number 3, question number 4. Right, paper number 3, question number 4. Question number 4. Right. That question says, a cyclist rides along a straight path with uniform velocity u and passes a motor car which is at rest. Yeah, the cyclist is this way, right? Moving this way, right? It's with velocity u, uniform velocity u. The motor car is resting here, right? Okay. At the same instant, the motor car starts to move in the same direction with uniform acceleration a until it attains the greatest velocity v. Acceleration, simple if, simple a. It moves with the acceleration simple a until it attains its greatest velocity v. Right. Up to velocity v, it moves with acceleration. Thereafter, it continues the journey with uniform velocity v. Right. Draw in the same diagram the velocity time graph for the motions of the cyclist and the motor car. Right. Okay. So then, when you draw the VT graph, time axis this is the velocity axis. The cyclist is now moving with constant velocity u like this. The cyclist. Right. Then car starting from rest and moves with acceleration. It gets a velocity v greater than u given, na? This way. Thereafter, it moves with velocity this way. Okay. This is the car. No? Then asking what? Deduce that within the period in which the motor car is behind the cyclist, the maximum distance between them is maximum distance. Right. Now, if I take this angle as theta, tan theta is the acceleration of the car given as simple a. This velocity is the greatest velocity of the car given as v, and also v greater than u given. You can see here, at this point, the velocity of the car and the cyclist become equal. Right? You know, this is how we explain the situation. Consider like this. Now, this cyclist, suppose his constant velocity is 10 meters per second. The cyclist moves with this velocity 10 meters per second continuously. The motor car starts from acceleration a. I'll take the acceleration is 1 meters per second squared. Then, to get the velocity 10 meters per second, this motor car takes 10 seconds. How? If we apply v equals u plus at for the car, initial velocity is 0, acceleration is 1, time is t, final velocity need 10, then you can see t equals 10. Right. After 10 seconds only, the motor car will get the velocity of the cyclist. After 10 seconds, suppose the cyclist is somewhere here, traveling this distance. After 10 seconds, suppose car is here. At that moment, car has the velocity 10 of this cyclist. Here, car has the 10 meters per second, here also 10 meters per second. Then you can see between them, there's a certain gap. This is a gap. Right. Now, next moment, what happened? Now, at this moment, the car and the cyclist, they have the same velocity. You know, velocity means what, people? In 1 second, displacement more. At this moment, car is behind the motorcycle and they are having the same velocity. But you know, the cyclist moves with the constant velocity 10 throughout its motion. But car moves, what, people? Car moves with acceleration until its velocity comes to v. At this moment, we can calculate the gap between them. This gap between them, you can very easily find in the VT graph. Right. Now, this is the VT graph of the cyclist. Until what? Until they have the same velocity. Here, at this moment, there's a time point, no, people, here. There's a certain time here. Suppose this time is t. During this time interval t, the motor car comes to the velocity u. That velocity is equal to the velocity of the cyclist. Now, during the time interval t, this is the VT graph of the cyclist. Below that, this whole area gives the displacement traveled by the cyclist during the time interval t, that is this whole area. During the same time interval, the displacement traveled by the car given by the area below this black one, this triangular area, that is given by this. Then, when they have the same velocity, the gap between the cyclist and the motor car, that is this, can easily be found subtracting this length from this. That means the distance traveled by the cyclist given by this area, no? Below this blue area. That of the motor car given by this area. Then their difference is this, the area I am shading. This area, therefore, should be this gap between them. Now, people, next moment, what happened? Next moment, because this car moves with the acceleration, next second, during the next second, the velocity of the car increases up to 11 meters per second. But cyclist having 10 meters per second. What happens there? During the next second, car moves forward 11 meters, but during the same second, cyclist can move only 10 meters forward. Then what happens? Car has moved 1 meter extra, greater than the cyclist moved. That means what? During the next second, the gap between the cyclist and the motor car reduces by 1 meter. Why? During that second, car moved more distance than what cyclist moved. After this moment, people, this moment means after they have the same velocity, after that moment, the motor car has greater velocity. Therefore, it moves more distance in a second than cyclist move. Then what happens? After the moment they have the same velocity, the motor car gradually coming closer and closer towards the cyclist. and one occasion, the motor car will overtake the cycle. So therefore, the gap between them become maximum when they have the same velocity. What is the gap between them? That is the maximum gap between them. Therefore, that maximum gap is given by this shaded area. Therefore, you have to find this shaded area. That is the question. Very simple question. Understand? Okay. Then you can write one sentence. Right? The maximum distance between them occurs when they have the same velocity. When they have the same velocity. Therefore, the maximum distance is given by the shaded area OAB. The shaded area OAB. And this area we have to find. This height is known. This length we have to find. That can easily be found. It is T, no? We can apply tan theta ratio here. Tan theta is what? Opposite side divided by the adjacent T. Tan theta is A acceleration. A equals U upon T. Then T equals U upon A. Then OAB area you can find half base into perpendicular height, no? Therefore, OAB area half base is T, U upon A, perpendicular height is U. It is U squared upon 2B. So this is the maximum gap between them. Right? This is how we take it down. Very simple question. Right, next question is a smooth wedge of mass 15 m is free to move on a long, smooth horizontal floor of a lift. The lift ascends with acceleration g by 10. A particle of mass 5m is released from a point on the face of the wedge, inclination alpha to the horizontal, so as to move down along the line of greatest slope of the face. Show that at any moment of the motion of the particle on the face, the normal reaction between the particle and the wedge is this. Right. This is another good question, right? Right. This way we have a lift. Here we have this way a wedge. Which moves this direction, rightward. The mass is 15 m, therefore weight is 15 mg. Let us take the acceleration of the wedge relative to Earth, relative to this lift as capital F. The particle moves this way, right? Suppose acceleration, simple lift, relative to the wedge. Its weight is mg, 5 mg, no? 5 mg. Right. Right. Now the lift is moving with acceleration g by t. Okay. Now asking the normal reaction between wedge and the particle. This is wedge and the particle. Are asking. Now I took the simple F as the acceleration of the particle relative to wedge. That means here, suppose the fly stands. Okay. It can see the particle is moving down along the face of the wedge with acceleration simple F. This capital F is the acceleration of the wedge relative to lift. That means in the lift there is another fly. That fly can see this wedge is moving this direction with acceleration F. Now suppose in the ground another observer observes this. Then the observer can see how the wedge is moving rightward with acceleration F. Meantime, since the wedge is inside the lift, wedge automatically gets the acceleration of the wedge. Therefore, this observer sees the wedge is moving this way with acceleration F. Meantime, it is moving upward with acceleration simple, this g by 10. And meantime, the same observer notices this particle, it moves rightward with acceleration capital F because the particle is on the wedge. Meantime, the same observer notices particle is meantime sliding down along the face simple F acceleration. Again, he notices furthermore, this particle is on the wedge. Wedge is inside the lift. Therefore, lift is moving upward. The same acceleration coming toward wedge. Since the particle is on the wedge also taking the acceleration of g by 10. Then this observer notices this has three accelerations. This way simple F, rightward capital F, upward g by 10. Understand? That is the finally, right? That is the finally, people, the acceleration of the particle relative to Earth. Okay, so we can write acceleration of the particle this way relative to Earth. Acceleration of the particle 5m relative to Earth. The direction is it gets this g by 10 acceleration upward. Rightward it gets capital F, and meantime it gets what? This simple F acceleration. The angle given here of the wedge is alpha, therefore this is alpha. Okay. Then acceleration of the wedge relative to Earth. Rightward capital F, upward v by 10. Right? Okay. Now asking what that R. Now we can first apply F equals ma for this particle down along the plane. Okay. Right. Now you can write applying F equals ma, number one, this direction, making an angle alpha for simple 5m. What is the component of weight, people? This direction 5mg sin m. 5mg sin m. That's all the force. 5mg sin alpha. All right. Right answer m means 5m acceleration relative to Earth along that direction. It is coming here, people. Here. This direction will be applied. Simple F is there. By this capital F, this direction component F cos alpha of the direction. G by 10, this direction sin alpha. Right? then simple F minus, right? Capital F cos alpha. And again, by this G by 10 also, people, the component distribution is A alpha, no, this is 90 minus alpha, G by 10 cos 90 minus alpha. That was active opposite direction, right? G by 10 sin alpha. This way we get that. This 5m and this you can cancel down. Then you can take here G sin alpha, right hand side F minus capital F cos alpha minus G by 10 sin alpha, bring this to this side. Then we get G sin alpha plus G by 10 sin alpha F minus capital F cos alpha. Here when you take common denominator, 10G sin alpha and G sin alpha means 11G sin alpha by 11 by 10. 11G sin alpha by 10 coming now. Then we get first the equation like this. Simple F minus capital F cos alpha is equal to 10G 11G sin alpha over 10. This is equation number 1. Now, secondly, we apply for the system. System means the wedge and the particle. That is the system. Number 2, for the wedge and the particle rightward direction. For the wedge and the particle, when we apply F equals mc rightward direction, no external force coming. By the flow of the lift, there will be a normal reaction here, R acting upward. That is vertical force. Horizontally, it has no component. So R also here we have no people. I take this as I take this as S. This is R. This S of force acting on the particle, the same is coming on the wedge also. This. When we consider wedge and the particle both as one object, this S and this S will cancel off. Right. Then we can say external force 0. The right hand side we must write people what? Product of mass and acceleration. There are two objects now. Wedge is 1. 15 m is the mass. Its acceleration relative to Earth rightward, capitally. And the other one is the particle. Mass is 5m. Acceleration relative to Earth rightward. It should be taken here, people. Capital F this way. F cos alpha leftward. Capital F minus simple F cos alpha. This we can cancel down by 5m. We get 3 here. Then here we get 3f and here f 4f come in. 4 capital F plus and minus minus simple F cos alpha is equal to 0. By this we can write people subject in simple F, take this to the side and divide by cos alpha. Then we get 4 capital F divided by cos alpha as our simple F. Okay. Now I am going to find this capital F because we need to find this S, the reaction acting on this particle. To find that, we have to apply F equals MA perpendicular to this face of the wedge, this direction. There we need this capital F. Therefore, we have to find that capital F first. Right. Right? Yeah. Then what I do is this. This simple F is substitute here. Then we can find capital F. By number 1. By number 1 you can write simple F is, for the simple F, I substitute this now for f over cos alpha. Minus f cos alpha equals 11g by 10 sin alpha. Take a common denominator as cos alpha for f here. If and this cos squared alpha. 11g by 10 sin alpha. Then capital F you can subject. Use the cross multiplication. So 1g by 10 sin alpha times cos alpha. Then capital F can be subjected by this. Capital F is coming like this. 11g sin alpha cos alpha divided by 10 times 4 minus cos squared alpha. Okay, no? Now we apply F equals ma for this particle perpendicular to the field. Right. Now we can say now applying F equals ma for simple m this direction. What do you get there? This direction is S pi mg cos alpha, S minus pi mg cos alpha. Correct, no? S is this direction form. This component, this direction 5 mg cos alpha should be equal to mass is 5m. Along that direction, the acceleration relative to Earth of the particle. That should be taken from here, people. It should be taken from here. Right. Perpendicular to here, perpendicular to this space only we apply that. Parallel to the face means the direction of F. Perpendicular to this direction means we have to draw a perpendicular line here to this F. Along this direction only we apply that now. This is 90. Right. Then along this direction, let's see what the component. Here this is alpha. This is 90 minus alpha. This angle is 90, therefore this is alpha. This angle is alpha. Then the component of g by 10 this direction is g by 10 cos alpha. This F doesn't give, simple F doesn't give. Why? It is perpendicular to this direction. Right. And by this capital F, let's see what the component. I produce this line this way. Right. When this is alpha, this angle is now 90, no? This is 90. This is alpha. Then the component of this F along this direction is F sin alpha. F sin alpha. Then this direction only we apply g by 10 cos alpha minus capital F sin alpha. Understand? G by 10 cos alpha minus capital F sin alpha. This is what we get when we apply F equals ma for this particle perpendicular plane. Now we have to find this is then what we do, we substitute for this capital F, this answer we got, and bring this right hand side and subject this, then we get this answer. Right. Now you can write substituting for F. Subject is taking that to right hand side, bring this to right hand side, and take this 5m out. Right. Then you have to take 5m out, take that right hand side. Take right hand side, that will be 5mg cos alpha. When you take 5m out, it is g cos alpha now. Right? Here, once you take this 5m out, within bracket we get g by 10 cos alpha. And minus capital sin alpha. There we can write sin alpha first and then substitute for this capital F. This answer we have put where here. Okay. Right. Then what do you get there? 11g sin alpha cos alpha divided by 10. Now we have simple values. People now within bracket with g cos alpha here, g cos alpha here, g and cos alpha here, common. Take that out. Then x is equal to 5m g cos alpha. You can take out. Then this will be 1 here, 1 upon 10 minus. When you take g cos alpha out, 11 sin squared alpha we have divided by 10. Like that. Okay. Now, I missed something. Capital F really people 7g sin alpha cos alpha divided by this no 10 times 4. This answer I didn't substitute there no. Cos squared alpha. Right? This F sin alpha no. I wrote only sin alpha. Next part is F. F means 11g sin alpha cos alpha divided by 10 times 4 minus cos squared alpha. Now only I wrote that. Then another this part should be there. Cos squared alpha. Right. Now you have to simplify this. Right. When you simplify this, what do you get there, people? Yes. 5mg cos alpha. We'll take this one as a common denominator. 10 times 4 minus cos squared alpha. Then this one will be, this should be multiplied by this. This one should be multiplied only by 4 minus cos squared alpha because already 10 is here. Then simplify this, you get this answer. Right. Here, if I simplify directly, here 10 plus 1, 11. 11 times 4 minus cos squared alpha. Now, correct, no? I simplify this. 10 plus 1 means 11 by 10. Then that 11 should be multiplied by this 4 minus cos squared alpha because 10 is there. And this one change. 11 sin squared alpha you can write as 1 minus cos squared alpha. You see. Okay. Then see what you get. 11 into 4, 44 minus 11. It's 33. Minus 11 cos squared alpha plus 11 cos squared alpha. That 2 will cancel log. Then here we have 33 numerator, that into this 5. Divided by this part. 5mg cos alpha. Multiplied by 33, divided by this. 10 4 minus cos squared alpha. Correct, no? Then this cos squared alpha I can write as 1 minus sin squared alpha. 5mg into 33 means 165, no? mg cos alpha divided by 10 times 4 minus, this is 1 minus sin squared alpha, no? Asking in terms of sin, no? Denominator, yeah. 1 minus sine square. Cos square alpha we can write as 1 minus sine square alpha. This is right. Then we can write S 165 mg cos alpha divided by, here in the bracket 4 minus 1 means 3, 10 times 3 minus and minus makes plus sine square alpha. This way we can take the term. Okay. Okay, next one, the Bose notation part. No. Bose notation part, right. Right. Question number 6. The framework ABCD is formed with 5 equal weightless rods. It is hinged smoothly at A. The weight W is suspended at C. A light inaccessible spring passing over a smooth pig P is attached to the joints A and D. DC is horizontal and PA is vertical. Find the pressure on the pig P by the spring. Find the reaction of the hinge at A. Find the stresses in the rods and distinguish between tension and thrust. That is the question. First, we'll draw the diagram there. Right. You see, we have the framework. Right. Diagram is this. Here we have a pulley. By the spring, there will be a tension acting to the joint here. Then the tension acts on the pulley. On the right end, this way, tension acts again on the pulley. At the point D, the tension acts towards this way. Then this tension and this tension act on the what? Structure framework. Now we know at A there is a hinge. You know, at a hinge, the reaction, it has no definite direction. For this, the reaction we mark by using two components, horizontally and vertically. We take horizontal vertical component as xy. This we will take right for direction, capital X, upwards, capital Y, and the weight W is suspended from me. I write that this way. Suspended means we can mark it like this. Finally, weight W acts at the joint C, no? Right. Now, phi equal weightless rod. Equal rods means the lengths are equal. Then each interior angle is 60 degrees. This way. Right. Now asking first part. Find the pressure on the pig P. This is the pig. Pressure means the resultant force of this P and T. That is the pressure. Pressure means the force acting on the pig. In this case, pressure means that. Force acting on the pig means this T acts rightward, this T acts downward. They have a resultant force. That is the final force acting on the pig Q. The two forces P and T perpendicular to each other. Their resultant can be found T squared plus T squared root. This answer is the pressure on the pig P. To find that, we have to find what? Tension T. So therefore, first of all, we have to take the tension T. To find tension T, what we do is, for the equilibrium of this framework, we take moment around A. Right. The forces which act on the framework are this X, this Y, this P, and this P, and this W. They are the forces acting on the framework. Subject to the action of those forces only, the framework is in equilibrium. Therefore, by considering the equilibrium of the framework, we take moment around A. Okay. We can now write for the equilibrium of the system, we take moment around A. Say clockwise sense we take. Clockwise sense. I'll take this length as simply the length of a rod. When I produce this line of action of weight W like this, this also 60. So what is this length? This is A, this is 60, therefore this length is A cos 60. When you take moment around A for this W, W multiplied by this length from here to here. This is A cos 60. Cos 60 is half, no? Then A by 2. A plus A by 2. It is 3A by 2. Okay. W into 3A by 2. Correct, no? 3A by 2 coming like this. I assume this length as A. Therefore, this all length being A. This is A. This is also A. This is 60. Therefore, this is A cos 60. Cos 60 is half. A by 2. This is A by 2. This is A. A plus A by 2. 3A by 2. Equal 3 times this force. T. So then the perpendicular distance is this from here to here. Then if this is A, this is also 60. No? A, this is sin 60. A sin 60. T into A sin 60. Sin 60 means root 3 by 2. This and this you can cancel down. You can cancel down. Then this root 3 and this 3 you can cancel down. We get root 3 there, no? Then we get root 3W equals 3. T equals root 3W. T equals root 3W. Okay. Then pressure on the peg P we can find. Right. T is root 3W now. And then we can write pressure. Pressure on P is equal to what? Square root of T square plus T square. What is that? 2T square, its root. What is that? Root 2 times T. But T is root 3W. Root 2 root 3 means root 6W. right? This is the pressure on the peg P. Next one asking, find the reaction of the hinge at A. X and Y we have to find. Reaction means the result of X and Y, yeah? Result of X and Y, we can find X squared plus Y squared root. That's how we find the result of two perpendicular forces. Then first we'll have to find X, right? Now how to find X? Right. Now we can write resolving forces acting on the system rightward. System means in the here the framework. On the framework, the forces acting now what? We say this W, this T, X and Y. Right. So then we resolve horizontally. This X should be equal to this T. Understand? X equals T. X equals. Right. Therefore, X is what? T is root 3 W. Yes. Resolve upwards, what do you get? Y plus T. Okay. This Y acts on the system. This T also acts on the system. Y plus T both upwards equal W. Equal W. Then Y can be found. W minus T. T means root 3 W. Take this W out. 1 minus root 3. People, you know, 1 minus root 3. This is really what? 1 minus root 3. Root 3 is 1.7 something. Root 3 greater than this 1. Therefore, this is negative. Therefore, the direction of Y should be downward. Okay. That's what it says. Okay. Y plus T is equal to W, no? Right. In my case, I have marked Y upwards, no? Right. Right. So then really, Y should be acting downward. Then I can write like this, Y equals minus W times root 3 minus 1. This minus sign I took out. Then minus root 3 will be plus root 3 minus 1. Therefore, this is positive. Since here we have a minus sign before, Y is negative. Y negative means the direction we have marked upwards, no? The direction should be down. That meaning Y negative. Then asking what? Reaction of the hinge at A. Reaction means now people, what? Reaction at A I can mark. Reaction at A. This way. X acting rightward. Now I am marking Y acting downward like this. X is this way. Then what is the value of Y? Downward direction this much. W times root 3 minus 1. X is root 3 W. They are resultant only. Of course, yes, they are resultant only. The reaction at A. Therefore, S is what? Root 3 W perfect square root 3 minus 1 times W perfect square. This is the reaction at the hinge. Right now. Now find the stresses in the rods and distinguish between tension and thrust. Right. Now we'll do that. Right. Right now, I take this diagram. Right. Why everything we know, with all things we know. Right. Now I'm going to cover this way. We need to find only the stresses in the rods, no? Then this time I can cover the structure this way. Huh? I'm going to cover the structure this way. I cover it like this. I cover it like this. Right. This joint not coming in the curved graph, but these two rods are coming. We need to find only the people stresses in the rods, no? Therefore, we cover this way, by this way covering all the rods available inside this. That way we can take this answer. But when I discussed this lesson in the class, theory class, I told you the whole structure we cover by this way closed curve. That also possible to use there. Right? That is actually important. If we try to find this reaction by using the stress diagram, that is important. But they have been found already. Now we need to find only the stresses available in the rod. Therefore, this way sufficient. Let's see how to draw the stress diagram for this one. First, now we'll mark the regions. Even I take this region as simple A. This region is A. This region I take as B. You have drawn another diagram. Your diagram is, of course, marked things in that. And this one I take as C. This one I take as D. This one I take as D. Right. Now we draw the stress diagram. Right. Now I'm going to the joint C first. This is a joint which has only two unknown forces. Therefore, we can draw the stress diagram to joint C first. Then after drawing that one, you can find this stress in the rod, this, no? Then we can come to joint this. It is a B, no? Right. Because there are two unknown forces. We can draw stress diagram here. Then this force in the rod, this we know the force, this we know. Then we can easily go toward the joint D. Then the stress in this rod also very easily coming. Right? Yeah. Now we can draw it like this. AB here. Come to joint C, rotate this direction. AB, downward W. This we will draw. AB, downward W. AB, downward W. BE horizontal. This we will draw horizontal line. Why? BE horizontal. EA or AE make 60 with the horizontal. A here. From the point A, draw a line parallel to that rod CB. Then we can find the point E. This is the point E. This 60. Right, no? Here, this is 90. Then we can come to the joint B. this joint B we can count. DA horizontal. DA horizontal. Then A is here, we draw to the point A or horizontal line like this. Here, on this line, the point D should lie. And next one, this rod. In the rod BD, it is given by ED. Point E is here. Through the point E, we have draw a line parallel to the rod BD, Through the point E, we have draw a line parallel to rod BD. E is here, parallel to BD. Now we have to draw a line. Parallel to BD means making 60 with the horizontal line. Then on this line, the point D should lie. On this line also, point D should lie. So therefore, point D should be here. This is 60. Or this is 60. Okay. Now we can come to the joint D. Right. When you come to joint D, we can see here. BC horizontal. BC horizontal. The value is T root 3W. BC. This. See somewhere here we have. Right? BC, we know. T is root 3W, no? Right. CD, when we join, that line should be parallel to AD rod. C here, D here. When we join this D and C, that should be parallel to that rod AD. Now, therefore, we draw a line to the point D parallel to that AD rod like this. Then that means this line, that point is this is also 60, because this line we drew parallel toward the rod AD. Therefore, this is 60. People, now we have drawn what? This stress diagram. Now we need the length. Right? The length you can very easily find. Yes. You can write this one. This is W, no? Then AE sine 60. AE sine 60. This is 60, this is AE. AE sine 60 means this length, W. Sine 60 is root 3 by 2. Then AE we can write 2W over root 3. Right. What is BE? BE you can write AE cos 60. AE is 2W over root 3. Cos 60 is half. This 2 you can cancel down. BE, W over root 3. And you know, this angle 60, this is 60, therefore this is 60. This is 60. Therefore, these three sides are equal to triangle. Similarly, this is 60, this is 60, this is also 60. Therefore, these two sides are equal. Then this 5 become equal. Okay. Then we can write what? This AE equal to AD equal to DE equal to CD equal to CE. Right? They all equal to what, people? 2W over root. Right. Okay, no? Right. Now, the last part. We'll decide here tension and thrust. For the equilibrium at the joint C, the force required this direction to balance this downward component. The other end this way. This is the thrust. This force will give horizontal component rightward to the joint C. Right? For the equilibrium, this is a force needed. Then here, this one should give that force. Other end should be like this. This is a tension. Right? People, now this force, when I consider this force will give vertically downward component to balance that upward component needed. Then this is that force which give upward component this way, other end this. This is the tension. This force will give leftward component this way. This also giving leftward component this way. To balance that rightward component needed, it is this way given by the rod AB, other end this way. This is therefore a thrust. Now come to this. This force will have vertically downward component. To balance that upward component needed, that force will right like this is also a thrust. So therefore, we know everything. Right. Now you can prepare what the table. What the table? Here we put the rod. Here the force. Right? Magnitude. And this one, tension and thrust. And now you can fill this. Right? No? First rod is AB and BC, CD and AD and BD. AB rod, here, this is a rod. Its force is given by this region is A, this region is D, DA or AD. Here it is, AD, 2W root 3. In that rod AB, there's a thrust. BC rod given by AE, 2W root 3 again. B C rod as a thrust. Like this, people, you can fill the table. Fill the table, right? Right. This is the end of the paper number